All right, let's break down something you do thousands of times a day, probably without even thinking about it: speaking. We're going to trace the incredible biological journey that a completely silent thought takes to become an actual spoken word.
You know, it feels instantaneous, doesn't it? You think of something and boom, you say it. But just under the surface, your body is conducting this incredibly complex, high-speed symphony of perfectly timed actions. So let's peel back the curtain on this everyday miracle.
The best way to really wrap your head around this is to think of your body as a super sophisticated sound system, like a speech machine. It's not just one single thing happening. It's a sequence of 4 different processes, all working in perfect harmony.
So, here are the big 4. First, you need a power source, and that's respiration. Then you have to actually generate a sound, which is phonation. Next, that raw sound gets its unique tone from resonation. And finally, articulation sculpts it into the words we recognize. All right, let's dive into each one.
Okay, first up, respiration. It all starts with something super basic, breath. But, and this is a really key point, speaking requires a very special kind of breathing. It's fundamentally different from the automatic breathing you're doing right now just to stay alive.
So think about it. When you're just sitting there, breathing is pretty even, right? In for a bit, out for a bit, about 50-50. But when we talk, we totally flip the script. We take this really quick sip of air, that's only about 15% of the cycle, and then we manage this long, slow, controlled exhale for the other 85%. That long exhale is the fuel for our sentences.
And that long 85% exhale is exactly why you can say a whole long sentence all in one go, instead of having to, take a breath after every single word. It's this really amazing act of muscular control that we all just completely take for granted.
So how does that air even get in there in the first place? Well, it's just straight up physics. Your diaphragm, which is the main muscle for breathing, it pulls down and makes your chest cavity bigger. And according to Boyle's law, when you increase the volume like that, the pressure inside drops. Nature hates a vacuum, so air from the outside rushes in to even things out. And just like that, you've inhaled.
Okay, so we've got our power source, this controlled stream of air. Now what? How do we actually make noise with it? Well, that's where step 2 comes in, a process called phonation.
Phonation is basically where we create the raw sound, and the main office for this whole operation, that's your larynx, or what pretty much everyone just calls the voice box. And inside are your vocal folds, and their job is to vibrate like crazy when that air from your lungs rushes past them.
And this cycle happens so fast. Here's how it works. First, muscles pull the vocal folds together so they're closed. Air pressure builds up from your lungs, kind of like water behind a dam. Then, pop. The pressure gets strong enough to blow them open, releasing one tiny puff of air. That release drops the pressure, and that, plus the fact that they're just naturally elastic, makes them snap right back together, ready to do it all over again. And when I say fast, I mean it's almost unbelievable. For an average woman, that entire cycle of opening and closing can happen up to 260 times per second. That's just mind-blowing. For men, it's still a crazy fast 120 times a second. And that rapid vibration? That's what creates the fundamental pitch of your voice.
Now here's a super important point. At this stage, we don't have words, we don't have speech. All the larynx produces is this raw sound, this glottal tone. You can really just think of it as a simple buzz. This is the raw material, the chunk of clay that the rest of our speech system is about to sculpt.
And that brings us to our final 2 steps. And honestly, these 2 work as a team. Resonation and articulation are the dynamic duo that take that raw buzz and transform it into the rich, complex sounds that we all recognize as speech.
So, let's break down this team. First, you've got resonation. This is all about shaping the tone. It's how we create our vowel sounds, our ahs, e's, and o's, by changing the shape of our throat, our mouth, and even our nasal cavities. Then, you've got articulation. This is where we get physical, using our tongue, teeth, and lips to stop, block, and redirect that air to sculpt the sound into consonants.
And here are the tools of the trade. You've got your movers and shakers, your tongue, your lips, your jaw, and then you have the fixed surfaces they work against, like the roof of your mouth or that little bumpy ridge right behind your top teeth. Go ahead and try it. Say ta, ta, ta. Feel where your tongue is hitting? That's articulation in action.
Okay, so we have this amazing, intricate biological machine. But who's running the show? I mean, all these parts have to be perfectly coordinated with split-second timing. And you guessed it, the director of this whole symphony is, of course, the brain.
The whole thing runs on your nervous system. And an easy way to think about it is this. The central nervous system, that's your brain and spinal cord, that's the main computer. And the peripheral nervous system, well, that's like all the cables and wires connecting that computer to all the different parts, carrying the commands out to the muscles.
Now, for most of us, language lives on the left side of the brain. A thought becomes a word by taking a little trip. It starts in Wernicke's area. That's where you figure out what you want to say. Then that idea gets sent over to Broca's area, which is like a choreographer planning out all the muscle movements. And finally, the motor cortex is the one that yells action and sends the final, precise commands down the line to your lips, tongue, and larynx.
And get this, the signals travel down two different pathways. Think of it like writing your name. There's one system, the extrapyramidal, that does the big, broad movement of just getting your arm over to the paper. Then there's another system, the pyramidal, that handles the super delicate, fine-tuned movements of your fingers as they form each letter. Speech needs both of those working in perfect tandem.
Okay, we've looked at all the individual players in the orchestra. So now, let's bring them all together. Let's watch the full symphony in action by tracing the journey of just one tiny two-letter word, B.
So you decide to say B. Here's what happens in a fraction of a second. Respiration. You start a controlled exhale. At the exact same moment, articulation. Your lips press together for the B sound. Then phonation kicks in. Your vocal folds start to vibrate. And as you release your lips, that sound flows into the final step, resonation, where your mouth and tongue shape that buzz into a clear E vowel. It's a perfect, high-speed, synchronized dance.
And just think, that absolutely insane, lightning-fast coordination happens for every single word, every single syllable you say. It's a non-stop ballet of breath, vibration, shape, and movement, all conducted by your brain. You know, we think of it as just talking, but it's really a biological miracle that you perform all day, every day. Kind of makes you think differently about your next conversation, doesn't it?